Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Your family, your community, your country, your responsibility. Be the best citizen you can be. Find the Bill of Rights on leadersa.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Riddy Clappy.
Okay, the Naked Scientist is joining us. Good morning to you, Chris.
Good morning.
Well, you should come to Joburg. I swear you'd think you're in London. It is gloomy, it is dark, pouring with rain, hailstorms everywhere. It's unbelievable.
No, I've come to Scotland for that. I'm in Aberdeen, which is almost as far north as you can go. Sort of civilization stops here-ish. It's 500 miles, so about 800 k's north of Cambridge, where I live, which is just north of London. And this is where most of the oil that comes from the North Sea comes into the British Isles. So this place is dubbed the Saudi Arabia of Scotland. The only oil I've seen, though, actually, is in the oil oozing out of deep-fried Mars bars and things that people are trying to push on you on street corners and stuff like that. No, I'm just kidding. But no, we're up here for the British Science Association Annual Science Festival. It happens every year. It's a different university every year. This year's the turn of Aberdeen, and actually the weather hasn't been too bad. It was rainy yesterday, but today I did make some vitamin D on the way in. It was slightly sunny, and the first couple of days it was nice and sunny. We've had some wonderful talks and presentations and things, but very enjoyable roundup of things. If people want to catch up, we're putting together a series of special podcasts from the festival, actually, on the Naked Scientist website. So from this week, if you go to nakedscientist.com, I'll tweet the links and things to @NakedScientist if you like. People can catch up with some of the interviews and the science stories, stuff on the Large Hadron Collider and ways to get energy out of old mines and why plastics are bad for us, that kind of thing.
Okay, thank you very much, Chris. Thank you. Let's get on with the program then. We have some lovely SMS questions that came through from last week, and we know that Neil Armstrong to be buried at sea. There's a question there around the landing on the moon, and it says, if the temperature on the moon varies from minus 150 degrees to 107, what camera/equipment did they use when Neil Armstrong landed on the moon to take photographs? Remember, there was no digital cameras back then. Secondly, how did the American flag withstand the extreme heat on the moon? What kind of material is it made from?
Okay, I can definitely do the flag situation, because lots of people say, why does the flag have ripples and all that kind of thing? I think that they used a lightweight aluminium material with things printed on it for the flag, and it has a wire which you sort of pulled out away from the flagpole to suspend the flag, because obviously there's no wind blowing on the moon in order to hold the flag upwards, so you needed something self-supporting. The camera question, that's an interesting one. I don't know what camera technology they were using. Of course, if you are thinking about the astronauts themselves, those spacesuits which take 5 hours or so for everyone to get into, they're all keeping the astronaut warm inside the suit. I think they probably had an equivalent for their camera technology, because on our Naked Scientist program, when Curiosity landed on Mars last month, we actually interviewed John Zarnecki, who is a scientist who sent the Cassini-Huygens mission to Titan, Saturn's largest moon. And he was explaining how when you design a space probe which will have to accommodate changes in temperature from thousands of degrees of certainly hundreds of degrees as the probe comes through the atmosphere to then minus hundreds of degrees on the surface. He said you plan for all this kind of thing, and you insulate these things very, very carefully and make sure that you recover every tiny trace of heat from the wires and things like that. And this keeps the electronics at just the right temperature. So I suspect they probably, but if anyone knows better, please tell me, I suspect they had insulated cameras that were designed to keep themselves warm using heat from batteries and so on, so that the camera could work under those temperatures. But it's an interesting question, one I haven't been asked before, and I don't know for sure. So if I got it wrong, I do apologise.
Very interesting question indeed. Let's go straight to the lines. And Justin in Bryanston, good morning.
Good morning, Rudy. What I'm wanting to know is how an electric toothbrush is charged, given that the charger itself is plastic on the top of the charger that fits into the electric toothbrush, and the bottom of the electric toothbrush is also plastic, yet the battery in the toothbrush charges if you leave it on the charger plugged into an electric circuit.
Yes, hello, Justin. The way these work is via a process called induction. Essentially, in the toothbrush base, there is a coil of wire, and you pass electricity with an alternating current through that wire, and this causes the wire to produce a magnetic field. One of the things that Michael Faraday and others discovered is that when a current passes along a wire, it produces a magnetic field. So if you pass an alternating current through the wire, you will produce a changing magnetic field. If you then put your toothbrush on top of that base, in the base of the toothbrush is another coil of wire. So the coil of wire in the toothbrush is now seeing a changing magnetic field produced by the coil in the charger unit. Because a wire in a changing magnetic field will therefore feel that field and will produce a current, you induce a current to flow in the wire inside the toothbrush, and the number of windings that are there determine what voltage is produced. This is then fed through a rectifier to turn it into DC from AC current, and that is then used to charge the battery in the toothbrush. And as a result, the toothbrush doesn't actually have to be physically connected, because the magnetic field that's actually passing the energy will pass through the plastic, unlike electricity, which would struggle to get through the plastic, because plastic's a relatively very good insulator.
Thank you very much, Justin. Thanks indeed, Justin in Bryanston. Let's go to, is it Paolo, who's calling us from Constantia in Pretoria? Good morning.
Morning. Just a quick one. The camera that they used on the moon was manufactured by Hasselblad, and I understand that it was a slide film anyway. The exact slide film they used, I don't know.
Okay.
But, yeah. Just one other little question I'd like to ask the scientist, if possible.
Yes, carry on, please.
The condition acute respiratory distress syndrome. I understand that I'm not fully understanding of what that is. Maybe you could give us a little bit on that.
Hello, Paolo, and thank you for your insights on the camera. Obviously, we don't yet know whether or not the camera is insulated to keep it nice and warm, but I guess maybe someone else can help us with that one. With respiratory distress syndrome, one cause of this can be pancreatitis. And what can happen is that the enzymes that your pancreas produces, which normally help with your digestion, including fat digesting enzymes, can end up in the bloodstream, and they then go into the lung, and they can dissolve the fatty substances, which are the surfactant molecules, which are there to reduce the surface tension of water on the inside of the air sacs in the lungs. And if you remove these surfactant molecules, then the tiny air spaces collapse on themselves, and as a result, the exchange surface is reduced, so the person can't actually breathe or exchange gases very efficiently. Other reasons why people can get acute respiratory distress: inhaling chemicals that can damage the lung, and anything that causes those sorts of inflammatory changes. And so it's usually a complication of the lung not exchanging gas properly, usually because there's been some kind of injury to the lung tissue or chemical change to the lung tissue, such as in the case of pancreatitis.
Thank you very much, Paolo. Thanks indeed. Let's go to Musa in Craig Hall. Hi.
Hi, guys. I just want to find out from the naked scientist. I know that while the baby is in the womb, the umbilical cord is able to do all the work, oxygen, food, and so on and so forth. But I know there's a fluid that's also keeping the baby comfortable. So I just want to find out, why doesn't it go into the baby's nose or ears, and then maybe it will do some kind of damage?
Suffocate the baby.
Yeah, exactly, something like that. Then why would there be that fluid and the umbilical cord at the same time?
Okay.
All right,
well, that's an excellent question. What a nice thought. The point about this is that the baby grows in a bag called the amniotic sac inside the uterus or the womb, and that bag fills with a certain volume of fluid, the amniotic fluid, And the point of that is that the baby is then suspended inside this bag of fluid, which protects the baby from sudden jarring shocks or pressure from the mum changing position or impact on the mum, so it cushions the baby. Where does that fluid come from? Well, it's actually the baby's urine, largely.
Oh.
Initially, the fluid comes from the tissue that makes the amniotic sac, but then as the baby begins to develop and has a primitive kidney, then the baby's wee forms or adds to the bulk of that fluid and makes the amniotic fluid. So it's baby urine. And the baby does drink that fluid because the fluid goes into the baby's nose and mouth, it goes down the baby's esophagus and into the baby's primitive gut, through the baby again, then back out through the kidney. And if the baby has a developmental problem such as the esophagus, the gullet doesn't form properly and you get something called esophageal atresia, then the baby can't drink the amniotic fluid, and as a result the amount of fluid builds up because the baby keeps on weeing but doesn't drink any of the fluid back, and you can get an excess of the amniotic fluid called polyhydramnios. This can be picked up on a scan and can warn doctors that the baby may have a disorder or an abnormality like that may need fixing when it comes out. So the baby does drink the fluid and it does pass through the baby, and the fluid balance is maintained by the fact that any excess can be pushed into the baby's bloodstream, and that is then exchanged with the mother's bloodstream via the umbilical cord. So they're all important.
Very interesting. Thank you very much, Musa and Craig Hall. Andre and Fishhook, stay on the line. We'll take your call right after this break.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Riddy Clappy.
12 minutes to 10 o'clock. Our lines are open for you. 021-446-0567, 011-883-0702. We are taking your SMSs on 31702 and 31567. Andre in Fishhook, hi.
Good morning, everybody. Morning, Chris. Morning, Riddy. Quick question. Why do all the athletes, seeing it's the Paralympics and Olympics at the moment, run anti-clockwise?
Oh, I don't know.
Okay.
That's a very good question. Sorry. Can someone help me out with this? Is this always convention? Because I must admit, I just watch the races.
Yeah,
I hadn't noticed
I
which direction they go around the track. I mean, it must be convention.
Yeah, I wonder. I don't know, Andre. Any of the athletes who are back in South Africa and they do want to tell us and answer our questions, please do that on 021-446-0567, 011-883-0702, and we are taking your SMSs as well on 31702 and 31567. Now, Chris, last week we had our healthy lifestyle feature. We're talking about taking care of your skin and the kind of sun protection you should go for. Now, there's an email here that says, please ask the Naked Scientist, why is it necessary to put on sunscreen when there is no sun?
Well, one reason for this is that even though you can't see the visible sun, the UV, which can burn, can still come through clouds to a certain extent. And so it's possible to still get sunburned even on a cloudy day when the visible light is being scattered by droplets in the clouds. So that would be the reason why they're cautioning you may still have instant radiation. And if you're at the beach, for example, even on a cloudy day, the UV can also reflect off the water as well if it's coming through cloud in that way, so you can get quite a strong dose, including also snowy places, because the same thing can happen, it can reflect off the snow. So I think that's probably the basis of that advice.
All right, and then Greg in Boksburg, hi.
Morning, guys. My question is about a GPS device and the speed indicated on it. Because if you're traveling at low speed, the GPS device gives you one number and your car speedometer another. But as you increase speed, the gap between the two increases. So I'd like to know which of the two is more accurate.
Hi, Greg. The way that the GPS system works is it's actually using Doppler, and it's using the relative time differences that the signals are arriving from the different satellites to resolve how fast you're going. It's actually doing this, though, with a margin of error, and it's also doing it over an average. So if you're travelling at a constant speed, the GPS will be extremely accurate. If you're travelling at very low speeds, because there's a margin of error with the GPS, because there's a degree with which it's imprecise over where exactly you are on the ground, it won't be very useful. And so, therefore, the thing I would rely on at a constant, decent speed would be the GPS. The odometer in the car is going to have a small margin of error because of the wear and tear on your tyres, because as the wheels as the tyres wear, the wheels are actually having to go around more to achieve the same speed than if the tyre is with a new tread, for example. So there'll be a very small error from that. Also, they tend to calibrate the odometers so that they overread rather than underread, and this protects you from being stopped by the police for going too quickly. So I find on my car, for example, when it says I'm doing a certain speed, the GPS says I'm actually doing about 8 kilometres an hour slower than my speedometer says in the car, although I haven't noticed that really that gap becomes much, much bigger as time goes on. So I would probably rely on the GPS at high and constant speed compared with my odometer for an accurate reading.
Thank you, Greg. And on 021-446-0567, Colleen is calling us from Scarborough in Cape Town. You've got an answer for why athletes race anti-clockwise.
Yes, Rudy and Chris. It's because when they come into the home straight, they're running from left to right, and that's always positive. You always you always go from your left hand to your right hand. I mean, you always see with arrows or anything, that's a positive thing. It's going, and graphs, it goes from the left to the right.
Ah, okay. That's one theory. I'm going to tweet this to our followers, at Naked Scientist, and ask them. Interestingly, Riti, I ran a little program yesterday asking where are your Twitter followers, because there's a function that will look and works out the geography of the people who follow you on Twitter.
Oh.
And an amazing result came up. Do you know how many, or what percentage of the Twitter followers for the Naked Scientists are in South Africa?
Tell me.
40%.
That is amazing.
It's amazing.
But I'm thrilled.
More than Britain.
I'm thrilled.
So South Africa is a very Twitter-enabled nation, I think.
Oh, that's stunning. I'm very, very happy. Thank you, South Africa. Let's go to Andre.
Thank you, South Africa.
Andre in Woodmead. Hi.
Hi there, Chris. Hi, Rudy. Chris, got a question about polarized lenses on sunglasses. If I look through my sunglasses, which have polarized lenses, and I look at let's say the radio in my motor car, the digital numbers are a certain color with my glasses on or off. But when I tilt my head to 45 degrees, the numbers change color. And in the same vein, if I'm looking through my glasses at a TFT screen or an iPad screen or a digital camera screen, when I look at the screen in a landscape, the screen is normal. But as soon as I turn the camera or the iPad into portrait, the screen or the image virtually disappears. Any idea why?
Hi, Greg. Right, well, I find this terribly hard to get my head around, so I apologise if I stuff it up, but I'll try. I think what's probably at the root of this is the way that LCD, liquid crystal displays, actually work, is that you have in an LCD display crystals that rotate the plane of polarised light. And so what you do is you have a polarising filter beneath the display with some light coming through it. It comes through the polarizer. It then hits the crystals, which, if you apply electricity to them, will change their configuration, which means they change the way they rotate light. You then have another polarizing filter on the top, and if the light that's coming through is in the same polarity as the polarizing filter, the light can come through. If the polarizing filter is actually at the opposite, 90 degrees to the light trying to come through the crystals, it will block the light, and so you either see transparent or you see dark. So the way that you make the numbers is by having it become dark in that bit. Now, your glasses are going to be polarizing light in the same sort of way to get rid of some of the extra wavelengths and dim down the light that's coming into your eye. So I suspect that when you're rotating the screen, the polarizing light that's coming off the screen is hitting your glasses, which are polarized at a slight angle to that, so you're cutting down the amount of light that can come through your glasses from the screen, and this makes it look a different color. I think that's probably what's going on.
Andrew, thank you very much for calling. Well, time does fly. My head is still spinning, Chris, from knowing that 40% of your followers come from South Africa. I'm really enjoying it.
It's amazing, yeah.
Oh,
it's a good little app you can get. Just look up where do my Twitter followers come from on the internet. Run this little app, and it tells you, and it gives you the sort of top 3 or 4. No answers yet, though, on the athletes running anti-clockwise. Lots of people are sort of retweeting it, so if I get an answer, I'll tweet it out.
Okay, thank you very much, Chris. We'll chat again next week, eh?
I'm looking forward to it. Thanks, Rudy. Bye-bye.
Bye. And of course, that conversation will be available as a podcast. The Naked Scientists are on Twitter, and you can follow them at The Naked Scientists. It's as simple as that. Follow them at The Naked Scientists. But for more about their work, you can visit their website as well at www.thenakedscientists.com.